All right, finally, we're going to just look at the transitivity of growth rates. Okay, I don't know if you recall the transitive property, but essentially here's what the transitivity of growing rates means. If f grows at the same rate as g, as x goes to infinity, and g grows at the same rate of h, then f and h also have to grow at the same rate as x goes to infinity. Okay, and the reason that that works is if I look at this right here, right, this says that f and g grow at the same rate because the answer of the limit as x goes to infinity of their ratio is some non-zero constant, right? And if I look at g compared to h, I get some non-zero constant, okay? And so together, that implies that the limit as x goes to infinity of f over h is the same thing as the limit of f over g times g over h, because I could cancel out those g's, right? But I can also think about that limit as the limit as x goes to infinity of f over g times the limit as x goes to infinity of g over h. Okay, and so that would just be L from above times M from above, and so that's why f over h is the same thing as L times M. Now, if L times M, if L is some non-zero number and M is some non-zero constant, then when you multiply them, you also get some non-zero constant, and so it is okay to say that they grow at the same rate as well. Okay, so how could you actually use this? That's the big question. Show that f of x equals the square root of x squared plus 5 and g of x equals 2 root x minus 1 quantity squared grow at the same rate. Okay, if we can show that f of x grows at the same rate as g of x, we can show they both grow at the same rate as another easier function, because doing this ratio would be particularly ugly. And so here's my goal. My goal is to figure out some h of x that would be easier to compare them to. If I could prove f and h grow at the same rate and h and g grow at the same rate, then f and g would have to grow at the same rate by transitivity. So can I think of something easier to compare them to? Okay, and here is what I'm going to pick. I'm going to pick h of x equals x. And you might say, how would I know to pick that? Okay, and what I would tell you is, here, right, the kind of domineering part of that is the square root of x squared, which simplified as x. And here, this would be the important part of this one, and the square root of x squared is also x. And so it makes sense that I would be comparing those. Okay, now I have to show that f and h are the same. So grow the same rate. And then after that, I'm going to show that h and g grow at the same rate. If those are both true, then I can show that f and g grow at the same rate by transitivity. Okay. All right, so let's take this question first. Okay, so I'm going to do the limit as x goes to infinity of f. So that's the square root of x squared plus 5 divided by x. Before I actually try to do this limit, I am going to do a little bit of rewriting. We saw this a little bit with arc length, so that hopefully this isn't too surprising, but one way to write x is to write the square root of x squared. So this is equivalent to the previous one, but now that it's underneath the square root, it gives me a little bit more freedom in ways that I am able to manipulate it algebraically. Okay, so I can call this the same thing as the square root of x squared plus 5 over x squared. And then I can break that up into two separate fractions. The limit as x goes to infinity of the square root of 1 plus 5 over x squared. And now when I actually evaluate this, this is pretty easy. Okay, remember that you can take the limit inside another function. So I can go ahead and either think about it like this or actually write this either way. Okay, the limit as x goes to infinity of 1 is 1. And as x gets really, really big here, this fraction is going to get really, really small. And so this is the same thing as the square root of 1 plus 0, or just 1, which is a non-zero constant, right? So f and h grow at the same rate. All right, so now my plan is to worry about this statement. Do h and g grow at the same rate? Okay, so I'm going to set up that limit, the limit as x goes to infinity of 2 square root of x minus 1 quantity squared over x. Okay, and I think here is another case where rewriting the bottom would be helpful, right? So that I can kind of algebraically do some manipulation. And so what we know is x is the same thing as the square root of x squared. So I'm just rewriting the bottom in a different way so that I have matching functions that I can algebraically manipulate. Okay, so basically this is the same thing as 2 root x minus 1 over square root of x, that whole quantity squared. And now I can do the same thing where I can algebraically rewrite. So the limit as x goes to infinity of 2 square root of x over square root of x, that's just 2, minus 1 over root x, that whole thing squared. Remember, with composition of functions, we just talked about this, you can bring the limit inside. Okay. And so when I do the limit as x goes to infinity of 2, right, that's just 2. And the limit as x goes to infinity of 1 over square root of 0, this part is getting really, really big. 1 divided by something really, really big is something really, really small. And so I have 2 minus 0 quantity squared, or 4. Again, the important part is this is a non-zero constant. And so what I just saw is g and h grow at the same rate. Okay. And so I know for sure by transitivity then, okay, if I want to show that f and g grow at the same rate, I can use that property on the previous slide. Okay, so if I want to do f of g, right, that's the same thing as the limit as x goes to infinity of f to h times h to g. Okay, so this would be 1 from the previous one, right? That's the answer we got above. We didn't do h to g, we did g to h, and so all I have to do is do the reciprocal of this. That's 4 over 1, so this would be 1/4. And my answer is 1/4, which is a non-zero constant, right? And so, therefore, f and g grow at the same rate. Okay. If you finish listening to this and you now have homework time, part of your homework is a worksheet. You can either get it from the sub or grab an electronic copy off Canvas and just do your work on a piece of paper to turn in with the rest of your homework. Okay. Hope you have a great rest of your day.